probability of A and B, union and intersection. So here we're going to use this relationship for probabilities involving unions and intersections. So we've got the probability of A union B equals the probability of A plus the probability of B minus the probability of A intersection B. And remember, we think of union as or and intersection as and. So let's jump straight into a question. So if we have two events A and B such that the probability of A is 0.4, the probability of B is 0.7, and the probability of A union B is 0.8, we want to find the probability of A intersection B. So we can go ahead and just use our formula. If we know the probability of A union B is 0.8, it's going to equal the probability of A, 0.4, plus the probability of B, 0.7, minus the probability of A intersection B. So we just get 0.8 equals 1.1 minus probability of A intersection B. And we just want to make probability of A intersection B the subject. So we add that over and minus the 0.8 to both sides. So we get the probability being 0.3 for A intersection B. Let's try another question, this time with a Venn diagram. Got our Venn diagram of two events, A and B, where in just A we have 3, in B we have 4, and then in the intersection we have 2, and then we have 6 elements in neither. So first we want to find the number of elements in the complement of A. So the complement of A is everything that's not in A. So in A we have 5 elements in total. So these two are not in A, so we get 10. What about the number of elements in the complement of A intersection the complement of B? Well, if it's not going to be in A and not going to be in B, it has to be the elements out here, so we get 6. What about the number of elements in A union B? Well, these are going to be the number of elements altogether in A and B, so they just have to be in A or B. So as long as they're in A or B, we count them up for the number of elements, and that's going to give us 9. What about the probability of A? Well, in A, we have 5 elements out of the total 6, 4, 3 and 2 is 15. So we might just write a 15 up here just to remind us. So our probability of A is going to be 5 out of our 15 in total, which will simplify to 1 on 3. What about the probability of A intersection B? So the intersection is A and B, and the elements in A and B is just 2. So it's 2 out of the 15 to give our probability. What about the probability of A and the intersection of the complement of B. So it's where these two things overlap. So the elements in A are 5, and the ones not in B, well, that's just these 3. It's where both of these things overlap, because we have 5 elements in A, and the ones not in B, out of those, are just 3. So it has to be 3 out of 15, which will simplify to 1 out of 5. And finally, we get are the events A and B mutually exclusive? And we can say, no, they're not, because the probability of A intersection B is not equal to 0. So as long as there's something here, they're not mutually exclusive.